Hello. Today we discuss terms used in magnetism for classifying the magnetic materials. We already studied certain terms called magnetic field induction, permeability, relative permeability, and permeability of free space. All these are the terms we already used in magnetism. In addition to this, we will be using two more terms. They are: one, magnetizing field, denoted by H vector. Sometimes it's also known as magnetizing field intensity or magnetizing force. This is nothing but that which magnetizes a material. Now we know that suppose we take a iron piece, iron rod, and I want that laminated wires over it, and if I send a current through this coil, you can find that the material inside this coil is getting magnetized. This is how we are making the electromagnets. Now, if you analyze it closely, suppose I increase the number of turns, the magnetism produced will be more. And also, if I increase the strength of the current, then also we can find the magnetism produced will be increasing. So actually, when you send a current through this coil, a magnetic field is developed, and this magnetic field inside that coil can be taken as mu into N into I, where the material is kept there inside. So core is acting as see that iron core is acting as the medium there inside, therefore we have to take it like this. Then, as the number of turns increasing and the current is increasing, the magnetism produced is found to be increasing. So actually, this particular quantity is responsible for the magnetization of the material. And this particular quantity, we can take it as H. Therefore, we can write V equal to mu into H. Now, what is magnetizing field intensity? If you are asked to define this one, you can define it as the ampere turns per meter length. Ampere turns per meter length used in magnetization is called magnetizing field. So H is equal to N into I, or equal to N into I divided by Kelvin, and therefore the unit of H is equal to ampere per meter. Okay. So this is magnetizing field, which is responsible for the magnetization of the material. Now, the next term, if we use, we can find that second one as intensity of magnetization. intensity of magnetization or simply magnetization denoted by I vector. Now, what does this magnetization means? It is nothing but by applying the magnetizing field, up to what extent the material is getting magnetized is called magnetization, or it is the amount of magnetism produced or stored in the material which is getting magnetized. Okay? Then how we can measure this magnetization? This is very simple to understand. Now let us assume that the material which is getting magnetized or we are using for magnetizing, let us take it as a iron rod. This iron rod is having the atoms which possesses dipole moment. Means each atom is acting as a magnetic dipole moment. So in the normal state, all those magnetic dipole moments will be aligned in random orientation, so that this random orientation will be making the net magnetism 0 in. Now when you start magnetizing the material using a magnetizing field, you can see gradually this orientation, the closed loops and random orientation is getting disturbed, and the external magnetizing field is making them to break the loop slowly, and gradually all these atomic dipoles are starting to align in a particular direction. Now this alignment of atomic dipole moment inside the material is creating the magnetism inside. And as you go on increasing the magnetizing field, you can see more and more atomic dipoles are getting aligned, and a stage reaches where the whole atoms of that material is getting aligned and the magnetism will be maximum in it. So when you take the alignment of material like this is the south pole and this is the north pole as per the direction of the dipole moment. Therefore this end of the material acts as south pole, and effectively this end acts as north pole. Now this is how the polarity of the magnet is arising. And in between, the effect will be nullified because of this closeness of north and south pole. So around the body length there is no attraction found, only at the ends. We call it as poles, the magnetism is formed. Okay? Now, how to measure this intensity of magnetization or magnetization? This can be defined as the total magnetic dipole moment aligned per volume of the material. Total dipole moment aligned per volume of the material is taken as the magnetization, and this will be nothing but equal to 2L into force strength divided by volume, L into area of cross section, and therefore unit wise if you take, you will be getting this as equal to ampere per meter cube. Because force strength, dipole moment is ampere meter square divided by volume meter cube, that will be ampere per meter. So effectively the magnetization and the magnetizing field are having the same unit and dimensional form. Now what actually the difference between the two? It's very simple. Magnetization is the effect which is produced by the magnetizing field which is acting as the cause. So H is the cause and I is the effect. So these two are the additional terms you are supposed to remember for the classification of magnetic mediation.